Alright everybody, and welcome to the second part of our EasyC version 5 tutorials. Today we're going to just start on a very basic program for a VEX Recbot, which is a provided design that VEX gives on their website. I will link a copy of the tutorial to make it in my description, just in case you guys want to use it. I did modify it slightly to use the 292 PMV motors instead of the 3-wire ones that it says for you to use. Alright, so to start up, we're going to start with a new standalone project. For now, we're going to put a autonomous only project, and remember that this can be changed later on in our tools window. So right now we are in our we start off our program by, before doing anything, File, Save Project As. You might want to select your directory. I already have it on the folder I want, but maybe you want it on your desktop instead of the default program. And for this, we're going to say Recbot Video Program. Sorry, my keyboard's loud, I know. I need to get a new one. Alright, and then from there, version 1. Not version exclamation mark, version 1. The second thing I do when I start a program is I do my configuration, especially with a robot like the Recbot that has a lot of motors, or it has 3 different motors, and it has about 6 or 7 sensors on it, each 2 optical quad encoders and an ultrasonic, which have 2 inputs each. And so I'd have to go through and left underscore drive, and from there I would give all of my inputs for my motors and my sensors in. For convenience, I'm just going to export one from or import one from a different file that I made a while back. Should be somewhere in here. Oh, that's probably why. It's gonna be in Recbot programming here. Okay. There we go. Import. Yes. And then for configuration, it has all my stuff in it already. That way you don't have to sit here as I do that. Alright, so now that we have put our configuration in, the next thing that I do from there is I go into my Project Explorer and open my readme.txt and put a brief descriptor of what this program is going to do. Basic program designed to teach programming to young robotics students. From there, you're going to put who it's written by, that being my name. Way to go me for being able to type in my name. A contact email or a phone number if you're willing to give that out. And then if it's designed for something such as YouTube like this one, you're going to put YouTube, and then from there you'll copy paste the URL. Obviously I haven't uploaded the video yet, so I don't have the URL, but that'll go in later. So then we're going to go back to our main. Now we must decide what we want our program to do. For now, let's just set it to drive forward indefinitely. Before we can just, set our motors to run and do whatever they want to do, we should probably test them first. And there's a really helpful thing in the tools window called the online window. the online window is going to open this crazy looking test page where you can set, well, first, before you can do anything, you have to enable it. That's kind of a helpful thing to do. And it's going to give you information from all of your analog outputs, all your digital outputs, and a way for you to toggle your different motors. Alright, so I'm going to really quickly jump over to my camera, in which I have it open up for you. Is that on the camera? It is. Alright, so you guys should be looking at my camera now. You should see the Recbot I have. I'm going to pick it up. Motor 1, I'm going to move the slider to the red area so it'll run. Okay, it's not running because I foolishly forgot to turn my brain on. Always make sure you do that. So you can just slide it over and you can just give it random values and you can just run it with all of your motors. My two movement are 1 and 10. And my crane is going to be, I'm going to set it down for that one because I don't want to break my hand. My crane is going to be on number 2, which does not seem okay. For some reason, it does not want to go down, but it will very happily go up. I will have to look into it. Alright, so from there, let's switch back to EZC. Minimize that. Alright, so we're back to our online window. Alright, so from there, just if you want to run the motor, just run your slider and it will do that. I really hope that captured the camera because I couldn't see it. And that could be a lot of editing for me to do. You can also detect your sensors. So if you look down here on analog number 6, as I move my crane up and down, that value is changing because that is my potentiometer. If you saw, my main battery just went down from 8 to 7.9. This is also a good way to just really quickly check what your battery is. You have all of your descriptions here, and you can edit them from here as well if you wanted to add them. Usually I just keep it on show to find. And then before you exit the online window, always remember to hit disable, or else your program will not run. So if we are going to run a motor, we don't need any set of motor. We don't need a variable or a global to run a motor because the descriptor up here, these number 1, 2, 3, 4, and 5 will act as our variable, and we will be defining it inside of our motor module, which is under our output block. And to put a block on, you just click it, and you click it in the function blocks, and you drag it onto your work line. From here, our first drop down will be our motor selector. From here we can determine which motor we want to work with. For now we're going to put left drive, and we're going to put it to run counterclockwise, which numerically has a value of positive 127. If you're running EZC version 4 or below, this would be a 0, and this would be 150, or this and clockwise would be 254, with stop being the precise center of that. Alright, so another thing we want to do with every program is we want to comment on every block so that anybody who's reading or looking at this program on their own computer that maybe we had given the program to or downloaded off the internet, if you wanted to put it up there on maybe the VEX forums, so that they can follow our logic. So here we're going to comment what the motor does. And a comment isn't like, hey, what's up, how you doing? It's more of a, what does this block do and what do you need to know about it? So set left drive to run counterclockwise. And then usually I will just put a 127 in there just because it's helpful. And then enter. So when you see our comment is going to show up on our set left drive to run, or on our set motor. If we wanted our robot to move forward, we need our right motor to run as well. So you could go through the process of dragging another one. I usually just copy and paste it, and then from there you can either double click it or you can hit edit block by right clicking, and then from there you can change it to the 10. Because I'm using the 2 wires, it should automatically adjust if I set them both to counterclockwise, and I can just change my comment right there. So right drive to run counterclockwise, 127. If you're going to use the smaller 3-wire PMV motors, you're going to have to run one counterclockwise and one clockwise because it will, because these motors are designed to adjust. I'm pretty sure. I could be wrong. Problem solving is part of the engineering process, and being wrong is a good thing, actually. Okay. So now that our program is maybe ready to go into our brain, we have to build and download the program, which will be output in our output and task windows. And to do that, we're going to go up here and hit the build and download tab and hit build and download. Or you can just hit F7. That's what I usually do. If you're on Windows, you have to hit the function or FN key, which is on the bottom. If you're on Mac, it'll just automatically default to the function 7 key. So when you usually download a program, it will ask you to, it'll say cannot find build location, and it'll ask you to either not save the changes to your program upon downloading, to save it, or to prompt to save. I always hit prompt because that way if I don't want to save the changes, if I'm just testing something, I can just hit X and then have my original program without it being edited, which is also a help for the whole version thing. Alright, I do want to save my changes because this is the first copy. And it's going to hit say please wait. Once this is done, it will download, or it'll bring up this pop-up window which says the hex file was successfully built. Would you like to download the program? Hit yes, or you can hit enter. The program will not download if your robot is not turned on, and it will give you all of the information. Oh, the robot started running. That made me jump. Alright, so as you can probably hear in the background, the motors are running. I'm going to switch over to my camera again so that you can see it. Alright, so it's going to just run backwards. Alright, now to stop the program, I can just turn off the brain or the cortex, and then I'm going to switch back to my EZC. Alright, I want it to drive forward instead of backwards like it was. So what am I going to do? I'm going to change it, and I'm going to change my comment. From there, copy. That's not what I wanted to do. Edit. Change your comment and your direction. I'm going to change over to the camera first this time. That's probably a smarter idea. And then I'm going to hit F7 once again to build and download my program. It'll run in just a second. Hopefully I didn't just move that out of frame. You have to make sure you turn on the battery before, if it... Alright, so now it's running forward. You can hopefully see. Turn off the battery again, and then hit X. So let's test our ultrasonic for a second. Switch back to our desktop. No, actually, I'm going to save the sensors and such as the ultrasonic for a different video. I'm running for 16 minutes. Alright, I'm trying to keep this one under 25 minutes. Alright, so what if we wanted to wait a certain amount of time? In your program flow window, you will have all of these conditions. One of these is a wait. You can always just drag and drop. A very good thing to remember about EZC is that for basic time operations, unless you are talking about competition timings, which is a one-time thing when you choose a new competition project, it will always account in milliseconds. So 1,000 milliseconds is 1 second. So what you see highlighted on the screen right now is 1 second. I want to wait 5 seconds. So 5,000 milliseconds equals 5 seconds. Comment. Wait 5 seconds. Enter. And now maybe afterwards I want to stop my motors. So it's going to run forward for 5 seconds and then stop. Paste. So from here I'm going to select stop. I'm going to change my comment. So 0. Set. Stop. Alright. You'll probably notice this user value as well. From here you can type in more specific values, like maybe I wanted, instead of -127, maybe I want it to be -54. -54, so that way it's still running, or -55 I guess. It's still running but not at full power. That would be running at a little under half power. You can also plug in the value of a variable here, which is very helpful if you are trying to use your optical quad encoders. But for the majority of the time, you'll stick to these counterclockwise and clockwise. Really bothers me that counterclockwise is red and stop is yellow. Kind of goes against every traffic law ever. But for now, we're going to set it to stop. We're going to, because this is our right, we're going to change it to our right drive, and then we're going to change our comment. And then hit OK. And then we are going to change our comment to stop. Enter. So now let us switch back to our camera. Let's readjust this while I can see it. Other way. Run back. Other way. Alright, and then let's build and download our program. Function F7. Enter. by the way, Greenway High Robotics is the group I am affiliated with. Remember to turn on your battery. I always forget to do that. So it is going to run forward for 5 seconds and then stop. Motors are stopped. I didn't change anything. Alright, so let's switch back to our programming. Alright, so everything is stopped. We can stop our intellect loader and close it. The intellect loader is good for displaying information if you use a display, which will be this print to screen. We'll talk about that more in our sensors video. And next time we will be covering, this is the end of the video, by the way. Thank you all for sticking around. Next time we are going to be covering the smart tasks, which includes a better way to autonomously drive our robot. All right. Thank you all for sticking around. Have a great day.